Hello everyone, welcome to Skills Academy. Today we are going to cover the topic of SQL Basic for SQL joins and subqueries. Here we are going to learn some of the use cases and syntax for inner join, left join, right join, outer join, and cross join. Along with that, we are also going to deep dive into what are the subqueries and what is the difference between correlated queries and non-correlated queries. So, to start with, let me just introduce myself. My name is Girish Kovlikar. I will be your instructor for today. I have over 16 plus years of extensive experience in data analytics, data engineering, data warehousing across various industry domains. I have also successfully led two data warehousing project implementation. Along with that, I am specialized in handling data with respect to technologies like SSIS, SSRS, SQL, Power BI, Microsoft Fabric, ADF, and many more. You can find my more career related detail over the LinkedIn link on the given page. Let's deep dive into what we have covered earlier first. So, in our previous chapters, we covered the basics of SQL, data types, what are the different kinds of commands we have in SQL, how we can do sorting and filtering of data with where, order by, having clause. How can we group the data and then do the sorting? We have seen some of the aggregate function. Now, in order to use SQL more efficiently, whenever you are using a relational database, you need to know about joins. And when you are handling a complex database or a complex relations, at that time you need to know about subqueries. To deep dive, let us start today's topic. First, we'll see the agenda, what all we are going to cover inside joins. We'll see what are the different types of joins we have in SQL. Then we will see some of the syntaxes along with some practical use cases and examples. We will see what do you mean by subquery with respect to SQL, how it will be useful for querying the data with subquery. We will see two types of subquery here. One is correlated and one is non-correlated subqueries. Later we will see what are the different best practices with respect to joins and using subqueries. Which one is more efficient? Let's deep dive into joins. What do you mean by joins? Join is nothing but when you join two different tables on a common column, which are identifiable their attribute by joining two different tables. So let's say, for example, we have customer table, we have address table. We can store customer's address in different table, because if we store in the same table, we might redundant the data of customer for storing his office address, his home address, his permanent address, and so on. So to reduce that, we separate the customer's table and the address table separately, and we store the address table with different attributes of customer. Like we store home address, we have one address, we have office address is different address. We might have third address, a delivery address. It could be a different, right? So in that particular case, we have to use join in order to find which address or which different address customer wants to use. Here in SQL, we have multiple types of join. First is inner join, which is mostly used in most of the queries wherever we have one-to-one relations. Second, we have left join, or it is also called left outer join, where all the data from the left table is considered and only the matching rows from the right table are considered. We will see deep dive with examples when to use which kind of join. Then we have right join, similar to the left join, but in the opposite direction. Here we will take all the right tables data first and all the matching records of the left table. Whereas in full outer join, we will take both the tables data together, and wherever the data is matching, we will display. If not matching, we will display it as null. Lastly, we have cross join. Cross join is nothing but a Cartesian product of the number of row present in both the join table. So let's say, for example, one table has 4 rows and other table has 3 rows. Then the Cartesian product of these will be 12. Hence, the output of the join will contain 12 different records. We will also going to see some of the scenarios for cross join as well. To start with, let us deep dive what is inner join. To explain you more understandable way, here is a diagram where we are joining two different tables, table 1 and table 2. In inner join, what happens is whatever data is common between these two tables will be shown to the result. Now, what is the syntax? Here what we do is select, we will write the name of the columns from table 1 and table 2 which we want to display. Then we will write from table 1 inner join. We are doing an inner join over here, right? Then we will see the joining condition. So we are joining inner joining table 2 on a specific set of columns from table 1 and table 2. Let us see one example for the same. Here is a scenario where you have been requested to join order and customer table to find order placed by each customer. So here it's a very simple, straightforward join. We are joining order table with customer table on customer ID, and we are going to display the customer name and order ID. To explain more, let us see the example. Now, here, if you see, we have the inner join. When I run this particular step, it will return me all the data from table where a customer ID is matched with the sales order ID. So here I am getting, if you see in the records, I am getting 32 rows. So there are total 32 orders has been placed by customers. So it can be a repetitive customers because since we are joining with the customer, right? So we are getting multiple customer which may have multiple orders. Those will be displayed. Now, let us see a next kind of join. Here, we will see the next join, which is left join. Now, what happens with the left join? In the left join, whatever data present in the left side of the table is fully pulled, whereas for the data which is on the right side of the table will be pulled only for the matching records. If the data is not matching, it will not display in the query or in the query result. Quickly, we'll just look at the syntax. Select columns from either table 1 or table 2. From table 1, left join table 2 on table 1 dot column is equal to table 2 dot column name. So here we have just changed one keyword from inner to the left join. It's so simple to use join when you start practicing it. Let us take a scenario. Here, there is a request to find all customers and their order, including those with no orders. Means we are getting all the customers from the customer tables, and wherever we have the order, we are getting the orders. Quite simple. We will join customer table with the order table, where customer ID from the customer table matches with the customer ID of the order tables. In this particular case, we will get all the customer names from the customer tables, and wherever we have the matching row from the orders for that customer, we will get the order ID. Let's say, for example, if any customer has not placed any order, in that particular case, this order ID will be replaced as null, or it will be shown as null, because that customer has not placed any order and there is no data from the order table to be shown. So remember, whenever there is no matching data is present, the null value will be displayed at that point of time. To give you a live example, let us go back to our practice. Now, here we have the second example for the left join. Similar to our example, we are joining customer table with order table, where customer ID and customer ID from the order table is matching. Now, let us try to run and see how much data we get. Okay, if you see over here, we have total 847 customers, out of which if we move it as a inner join, just to check how many customer has placed the orders, we are seeing only 32 customer has placed the order. Hence, when we use the left join, we get all the customer with the names, and wherever the order ID is not present, it is blank over here. I will just show you so that I'll just do order by descending so that we get the data on the top. Order by sales order ID unique. Just to get the data display. Now, here if you see, we are getting customer name and sales order ID. While after 32 rows, we will not see any of the order ID over here. The reason behind that is we are getting all the customer from the customer table and only matching record from the order table are displayed. Let's get back to our deck. Now, let us see the next example or the next type of join, which is nothing but a right join. Similar to the left join, what right join do is it pulls the data from the right table fully and only matching records from the left table are pulled. Wherever the data is not matching, it will display a null value. Similar to the left join syntax, we have the right join syntax. Here we are doing select column name from table 1, right join table 2 on table 1 dot column is equal to table 2 dot column. Here we are joining the common column like customer ID or order ID if we are going to get the details of orders. Next, let us see the example for right join. Find all orders corresponding to customers, including those without customer. This is a weird scenario, but let us see if we get the data in our given example. What happens is we are getting data for all the customers, even though if the order is not placed. So let's get back to our example over here. Here we will see the right joint example. So we are getting all the data from the orders table and only matching data for the customer table. Now remember, sometimes what happens is if you don't have the criteria matching, it will behave as an inner join because you are getting all the matching records only. In this particular case, we have seen the inner join was retrieving 32 rows. Similarly, right join is also retrieving 32 rows. Hence, this particular join is behaving like a inner join, but ideally it's a right join. Now, let us take one more example where we want to pull the data of customers where they have their address type in place. So here we have customer table and we have customer address table. In customer address, we have address type. So it can be a home address, it can be a office address. We are pulling all the address type of customer addresses. To get it, we are just running the query and we are seeing the total records are 857. So we have total of 857 customers, out of which only few of them are having address type populated. Similarly, we will just add the address type in the group by, or sorry, order by, so that we can get the results quickly. Here, if you see, a person has address type as shipping address, main office address, or many more. There are many main office address. If we add customer first name, comma last name, we will get some more filtration of the address or the grouping of the address. Now, if I run this, I will get for each customer multiple address. If you see over here, there are two rows. One is main and one is blank. So there is one blank address type. So it can be a multiple option or it can be having. Here in this case, it is not having the shipping address. That's why it is a blank over here. This is an example for the right join. Now, let us see what is the next type of join. Next, we have pull outer join. In this type of join, what happens is data from both the tables are pulled into the result set. But wherever the data is matched for both the table, the result set shows the data for that particular table or column. Else, whenever we do not find any matching values, a null value is displayed on the selected clause. Similar to the or left join and right join, we have the same syntax for the outer join. We have select column name from table 1, full outer join table 2 on table 1 dot column name is equal to table 2 dot column name. Let us see an example for the full outer join. Here we have asked to get the customers and orders where both the record either matches or not matches. To get that, we can write a simple outer join query that is select customer name, comma customer ID, comma order ID from customers, full outer join orders where customers dot customer ID is equal to orders dot order ID. This particular query will show all the data from customer table as well as from the order table. Also, Wherever the data is not matched for the customer ID, the null value is displayed. To get a more idea about it, let us see the example. Here, we are taking the same example of customer, address, and customer, where irrespective of the address type, we want to get the data to be displayed. Now, since we have we have the data in such a way that it works in a similar way, like a right join, because this particular table is having primary key and foreign key relation. In that, whenever the data is present in primary table, then only it will have the data in the child table. But you will get an idea about what happens if the customer ID doesn't match. In that particular case, we will see only the address type over here. This is an example for the full outer join. Now, let us get back to the deck and see what are the other type of joins. Next, we have cross join. Now, what do you mean by cross join? Cross join is nothing but whenever we are pulling the data from two tables, if table A and table B has 3 and 4 rows, the result will be output or the Cartesian product of the 4 rows and the 3 rows, which is 12 rows. If you see over here how the data is going to display, let's say for example, we have both the table with single columns. Here we have A, B, C as three different rows. We have 1, 2, 3 as three different rows in table B. Now, the result will be A1, A2, A3. Similar to that, we will have next set as B1, B2, B3, and C1, C2, and C3. This type of join is called as cross join. Let us see an syntax for it. It's very simple. We don't have to specify any joining condition in this type of join. Here, what happens is we just define the list of column to be displayed from both the tables. In order to do that, we just write select list of column to be displayed from table 1 cross join table 2. Let us see a quick example. If we have asked that to pull all the combination of car and color, we can write a cross join. To do that, what we do is we just write select car model, comma, color name from cars cross join color. Here, what happens is both the table has a single column displayed in the select clause. From both the tables, all the combinations of data is displayed. Let us see an example. Here in query 2, we have created this sample data for two different result set. First, we have colors. If you see colors, we have red, white, silver, and blue. Here we have four rows. Now, in the car, we have three rows. One is Ford, Toyota, and Lexus. Now, when we do a cross join between these two tables, we will get 12 rows. If you see over here, we are getting for each car model four different rows, which is red, Ford white, Ford silver, and Ford blue. Similar to that, we are getting Toyota red, white, silver, blue, and then Lexus red, white, silver, and blue. If you see the record count over here, it should be 12. This is an example of cross join. Let us get back to check the next topic, which is subqueries. Now, what do you mean by subquery? Subquery is something that whenever you are not able to find a result with a single query, you have to use a subquery to be passed to that single query so that you get an actual result. It is used whenever you are doing a complex calculation or you are grouping the data and based on that you are calculating the result or getting a customer name who is the top spender for particular order. Type of subqueries. One is correlated subqueries and the other is non-correlated subqueries. Let us see more about correlated subqueries. Correlated subqueries are something that can be run independently on its own, where the result of the outer query is used. The example for the correlated, non-correlated subqueries is syntax for it is select column name from table where column is equal to select value from another table where a condition is matching. There could be a condition that we need the data for US region. So let us take an example of find customer who placed the highest order. To get it, what we do is first we write the subqueries where select customer ID from order table where amount of order is the maximum. The maximum of amount is just taken into the where condition and we return that customer ID to this query result. Once the data is passed to this, it passed to the outer query and the outer query display the results. So when we have to use this particular query again is whenever we want to display data which are dependent on any aggregation function or any calculation which are cannot be computed with single select or join clause. Now, next we have correlated subqueries. In correlated subqueries, what we do is we give the reference of the outer table to the inner table. This type of query executes for each row. So whenever you're using correlated subquery, it will be time consuming and it will utilize the memory a lot. Syntax for that is select column name from table 1 where exist. Now here we are using a keyword called exist. Why? Because we want to see if the data is present in my child table or the subquery. Here we are joining with another table with a common condition. I would say maybe sales greater than $500 or sales greater than a specific number for a particular joining condition. So here what we are going to do is we are joining table 1 which is referred as outside table dot column is equal to another table which is the subqueries table and the column. Whenever you find this type of query, it is referred to as correlated subquery. Just to get a deep dive for this, let us get an example. Here we have asked to find the customer who have placed order more than once. To get that, what we do is we write a subquery so that we get the order tables data and we are joining the customer ID from the order table with the customer ID of the customer table having, since we are doing the grouping, right, having the count of order ID is greater than 1. So here we will get, if the record exists, it will return the row and only those customer will be displayed. It will display the list of all customers who have placed more than one order ID. Now, in order to decide, we will see what are the best practices for using the joints. First, in order to choose the right kind of joint, we need to understand the relationship. We need to know the table related to the different table. Based on that, we can decide whether we have to use inner join, left join, right join, full outer join, or a cross join. Similarly, minimize a data retrieval. If we use full outer join, it will retrieve whole amount of data. But we don't want to do that. Instead, it is better to use either left join or right join so that the result set is compressed and then the data is returned to the result. Third, use joint for relational data only. Whenever we are going to use the joints, make sure that both the tables has a relation between it, like primary key foreign key relationship, one to many, or one to one. This particular thing will help you to make a optimum use of the joints. Next, what are the best practices for the subqueries? First, prefer joints over subquery. The reason behind that is joints are more efficient than subqueries, and we sometimes get the same results. So why to use a subquery? Second, use CT for readability. CT is nothing but a common table expression which improves the readability of your SQL code. Also, CTE is used for storing the data in memory. We are going to cover the complex SQL topics or the advanced SQL topics in the next advanced session. So be present for that. Third, optimize correlated queries. Instead of correlated queries, try to convert in into joins or non-correlated queries so that it can it can be possible to optimize your data or optimize your queries. To conclude, let us see what we have covered for today. First, we have seen different types of joins in SQL. We have seen subqueries and its type. We have seen multiple example, a practical one as well for joins, and we have seen some of the scenario based queries for subqueries. Then we have seen the best practices. To give you more idea, you can refer the book SQL in 10 Minutes, Sam's Teach Yourself by Ben Forta, or you can refer a book called Learning SQL by Allen. You can find more documentation specific to this topic on vendors who are providing a DBMS solution, which is MS SQL, PostgreSQL, Oracle, or MS, um, or MySQL. If you have any query with respect to today's topic, or if you have any example in your mind and you're stuck for your example, just drop down your example in the comments. We will try to answer it as soon as possible. Or if you think that it is a confidential, you can email it to us on inquiry@skillsacademy.com. Thank you for attending this session. Hope you enjoyed this. See you in the next class.